In the earlier days, using principles of statistics, we managed quality with measures such as acceptable quality level AQL, average outgoing quality level AOQL, and so on. All these were in percentages. For instance, an AQL of 10% and AOQL of a few percentage points and so on. However, for the current need, these measures are grossly inadequate and inappropriate. We are looking for some mechanisms to deliver near zero defects in operations. Therefore, we need metrics commensurate to this requirement. If we want defects to really become an extraordinarily rare event, we can think of two measures. If you take the example of manufacturing, one possible measure is what is called parts per million defect rates, ppm. If you take services, a measure is called defects per million opportunities, DPMO. So both are equivalent. Six Sigma quality program uses these two measures when it comes to quality metrics. Parts per million defect is easily understandable. Essentially, you count the number of defects, and then if they are in certain parts per million, it is called ppm. That is easily understandable. Let us now look at the measure defects per million opportunities. So, if in a process, let us say the number of opportunities for making a defect per unit of execution of that process, let us call it as k. Let the number of units of observations of the process be n, let me use n as the variable, and the number of defects that occurred in that process during the observation is d. In other words, what we are saying is we observe n times, we actually found d defects. This is what we are talking about. Potentially each time there could have been k different possible defects, that is what this is suggesting. So, if you put these three together, then we will be able to get the defects per million opportunity, because this is the actual defects that we observed and this is the potential defects that could have happened in that process, and multiplied by a million you get defects per million opportunity. Let us take a numerical example to understand this. Let us say we are looking at a check-in process in a hotel. So, the potential opportunities to make a defect in a check-in process, let us say, is 11. Previous studies show that there are 11 possibilities. Taking the guest's name wrongly or not remembering to take certain details, like that, it could be some 11 possible ways by which defects can happen in that check-in process. In a certain season, let us say 1250 guests were handled through this check-in process, and there were 357 defects observed during that period. So, with this data we should be able to calculate, because it so happens we can use the formula defects per million opportunities is the number of defects observed over the potential defects, which is 1250 guests. Each would have potentially, there would have been a possibility of creating defects. So, this is the total number in the denominator and multiplied by a million, so that you get defects per million opportunities, which turns out to be 25,963. So, the DPMO for this process could be 25,963. The issue is that the new metrics fundamentally force you to rethink in terms of what is the overall framework for quality management. Today's quality management approach must be based on a few basic premises in order to achieve such parts per million defect levels. We shall see some of these basic premises of quality. The first premise is all quality initiatives must be continuous and data driven. It cannot be on hunch, it cannot be an one-time event. It is a continuous process. Only then such high quality levels can be sustained. The second premise, the system of quality that we need to put in place must be one of prevention and elimination and not detection and correction. There is no way we are going to get to parts per million defect rates by continuously detecting errors and correcting errors. That is just a starter. We need a system of prevention and elimination. That is the second premise. The third premise, the performance standard is zero defects. For practical purposes, we can go near zero defects, but the performance standard is going to be zero defects. Fourth premise, the responsibility for quality must lie primarily with those who produce and deliver products and services, and not with quality control department who can measure and find something. I think quality must be owned by those who create products and services through a process. These four premises are very important for us to move on to parts per million defect levels. Given these premises of quality management, it is clear that organizations need robust mechanisms in place to address these issues. So, in the next video, we shall see how a Six Sigma program can address these requirements in a structured way.